Hi, and welcome to the Solution Stoichiometry Pre-Lab, or just we'll call it the Solution Lab Pre-Lab. We're going to do some solution stoichiometry to make a certain amount of copper carbonate, as you can see there. So every group has got a different amount of copper carbonate, and we're going to walk you through the calculations first, and then in the second half of this, we'll talk about how to do this write-up that you should have done right up before you go into lab, so you're ready to collect all the data that you need to do that. So the very first thing you want to do is find the spreadsheet with your lab groups and look for the spreadsheet where your name is. And I made up a fake account for mine. Okay, so I put up some fake numbers for the demonstration I'll be doing today. Other people's numbers may be different. Okay, so you don't all have the same numbers, and certainly no one has the same numbers that I do. I just made some up. And the ultimate goal, as I mentioned, is to make a certain amount of copper carbonate, and we're going to see how close you can get to the actual number that you're supposed to make. That's the goal of this lab. And copper carbonate is an insoluble solid, so you're going to make some of it and it makes this big chunky blue sort of like solid, and you're going to filter it out. And I'm going to show you how to do that next time I see you when it is time for the actual demonstration of the pre-lab, but we're going to get all the data and calculations done before then to make sure that we know how to do it. Okay. So to make this copper carbonate, there's lots of ways you can do it. We're going to be using some sodium carbonate and copper chloride. Those are the two things that we're using, and they each have different concentrations. You can see my sodium carbonate is 2.14 molar, and my copper chloride is 1.6 molar. But just remember, it's going to be different than someone else's, so don't worry about what everyone else says. Every person might have a different amount of those two things. And I'm going to show you how to solve. Actually, you already know how to figure out how many grams of copper carbonate you need and the math associated with that. I'm going to show you how to do that right now. You'll be doing the same math. You might as well just do it right now, and you can copy it into the calculation section of your write-up when the time is right. So take a second to get all the stuff ready to do your own numbers. I'm going to do my numbers, and you can do the same thing. So we're going to start with the amount of copper carbonate that is desired, and we're going to convert both of these numbers, both of the molarities, into grams of copper carbonate. And the ultimate goal is to get, in my case, 26.3 grams of copper carbonate. That's like what the goal is. And everyone else's goal is going to be different, as we mentioned, like I think 1,000 times already. So let's just go on to the calculations. Calculations are super straightforward. We're going to start with the amount of copper carbonate that we need. And that's the 26.3 grams in my case. And we're trying to figure out how many liters or milliliters of each of these two things we would need. So we'll start with the sodium carbonate. We're going to need the molar mass of copper carbonate real quick, and a better teacher would have already had that figured out, but I'm not that teacher. So 63.5 plus 12 plus 16 times 3 gets us copper 2 carbonate, and it looks like it's 123.5 grams. That's the molar mass of the copper carbonate. And everyone's number will be the same there. So then this is 1 mole here, and then the mole ratio for the balance reaction. A better teacher would have already written the balance reaction, but we have sodium carbonate plus copper chloride, copper 2 chloride, and it's going to make, oh no, it's going to make copper carbonate, which we want. It's also going to make some sodium chloride, which we don't want. You can see that's the balance of 2 in front of that. Everything else is 1 to 1, so this is going to be 1 mole of copper carbonate for every 1 mole of sodium carbonate. Now the sodium carbonate has a concentration of 2.14, so we put that here, 2.14 moles in 1 liter, and we do the math real quick to calculate it out. 26.3 divided by 123.5 divided by 2.14, and we end up with 0.995 milliliters, or sorry, liters, 0.0995 milliliters, which of course equates to 99.5 milliliters. Wow, I'm so bad at this. This one should be liters, my apologies. There you go. And we'll do the other one real quick as well. So we take the same 26.3, and you have 1 mole over 123.5 grams. It's still a 1-to-1 ratio. This time it's copper chloride for every, copper carbonate on the bottom here, CO3, and 1 copper chloride on top. And now 1 liter of copper chloride, that's this one, is 1.67 moles. Liters, moles there. So take our 26.3, divide by a buck 23.5, and also divide by 1.67, and we end up with 0.127, which is 127, which is going to be liters, or 127 milliliters. What that means is that when we're ready to do this lab, I'm going to measure out 99.5 milliliters of the sodium carbonate. I'm going to measure out 127 milliliters of the copper chloride, and I'm going to mix them together and then filter them out. And if I do all of those things correct, what I should end up with is 6.3 grams of stuff. Okay, that's the ultimate goal. You want to replace your numbers, or my numbers, with your numbers. This will remain the same right here, and these will remain the same right there. And the only thing that will be different will be your concentration. So this number here will be different, and oopsie, this number there will also be different. So keep that in mind as you are doing this. Your number should be below 25 when you're doing this. Your number should be below 25. Okay, and I'm sorry, this number will also be different because your starting number is going to be different. So that's what's going to change for you as you do this, and you're going to want to put those calculations in the calculation section in just a moment. Okay. So there's our setup. There is our math required to do this. This is why we do solution stoichiometry. And now we're going to go ahead and write about, get the lab set up in terms of what we want to do for a lab write-up. You're going to write down from this point on every single thing that is written on this piece of digital screen, except where it says add a blank line. Okay, so you want to take a spot to find a piece of paper that you will turn in to me, so it has to look like decent, and we're going to talk about how to set it up and what you need to write down. Again, everything that you see from here on out has to be written down in your lab in a piece of paper that you will turn into me. You will absolutely 100% turn into me. So let's start. Again, wherever it says skip a line, you don't need to write that. Everything else you do need to write. Okay, so keep that in mind. On your paper, you're going to have the name and the date, and this is called the Solution Stoichiometry Lab. So please pause this whenever you need to write things down. And again, if our procedure doesn't make sense, it will when I demonstrate it for you next time I see you. So the purpose of this lab is to make a predetermined amount of copper to carbonate solid. So that's what I just showed you how to do mathematically, and we're going to do that in lab next. I already showed you the balance reaction. It looks like this. Make sure you have it copied down and ready to go, and skip a line between each of those two things. Okay, there's lots of different ways you can do this. We're going to go with a straight up simple, mix two liquids together, get a solid, filter it out. And the filtering part takes a little bit of time. So we're going to actually let it dry overnight and filter overnight for the best results. And hopefully we'll get those best results. I don't know. It's like very exciting. All right, so what you're going to do is you're going to calculate first the required volume of copper chloride and sodium carbonate required to produce the amount of the copper to carbonate solid. I already did that for you. Okay, that's what we just did. And you're going to put that down here where it says calculations. Okay, but you don't have to do that right now. You have to write all these words. Again, all of the words you're looking at, including the procedure. Write it all down. Next thing you do is measure the amount of calculated copper chloride. So you're going to take those two numbers we just found and measure them out using graduated cylinders. And you're going to add that to a beaker. And you're going to rinse each one of them just with a little bit of distilled water to make sure all of the stuff you put into the graduated cylinder gets into the beaker. And that's really important. Otherwise, these reactions won't go to completion and you'll get less than you desire or less than you're supposed to get. Okay, you're going to do the exact same thing for number two. For step two, you're going to repeat it, but now you're going to do the same thing for sodium carbonate. Again, those two numbers, you're just going to measure them out, and I'll show you again how to do that. Number four, record the mass of a piece of filter paper in a plastic weigh boat. Plastic weigh boats, you maybe don't know what it looks like. It's like a little tiny plastic ball, basically. But we want to make sure we have one of those because it might be easier for our filter paper to dry out in there. So we want to know the mass of our own filter paper and plastic weigh boat before we start. Those are two important things, and there's going to be a spot to record them in the data section. You're going to filter the product. You're actually going to mix the two of the things together, and you're going to wait for the solid to form and stir it around a little bit. So we make sure that we get the entire reaction to happen for step number 5, and I'll show you how to filter it in just a moment. Later when I see you next. And then finally, you're going to let the paper, use the filter paper in a plastic weigh boat, let it dry overnight. All of this will make sense when I show you, I assure you. And then the cleanup, because we're going to be short on beakers and graduated cylinders and OMI or flasks for filtering, is to make sure that you clean all of them. Again, a thing I will show you. There is the first day procedure. Now we let the product dry overnight, and so the next thing you want to do is after the next day when we come back, we're going to record that product, record the mass, the filter paper, and the weigh boat all together, and then I'll have a special spot to discard the filter paper in the hazardous waste, and then calculate the actual yield of copper carbonate is the last thing we'll do, which we can show you how to do in class, not a problem. So there's the first part of the procedure. Again, all the words written down on your paper. It will look just like my paper. Hopefully you pause because I'm going incredibly fast. The data you need to collect for this, mass of filter paper, mass of the plastic weigh boat, and mass of all three of those things together, and the dry product, which would be the second day. So this one actually is the second day. The first day you'll record these two things when they're dry and alone on a balance. Pretty straightforward. Next, calculations. The two volumes, we just showed you how to do that. That was on the previous, when we did the first part, we're setting things up. So make sure you have those calculations very visible, and I want to be able to see the two 3-step stoichiometry calculations. The mass of the product is just the subtraction of this guy minus these two things. Pretty straightforward to do. On the second day, you would do that. And then finally, the percent yield, which is actual over theoretical. It's basically what you really made divided by what I told you to make. Words are difficult. Then you skip a line and do a conclusion. The conclusion looks just like that, where you're saying I was assigned to make this many grams of copper carbonate. I actually made this many grams of copper carbonate. My percent yield was blah, and here are the reasons I may not have got that 100% yield. And you'll write those 3 reasons after you have done all the lab. Now this part, of course, you don't need to have in your lab. This is just me showing you how to do stuff. But otherwise, the rest of it is important and required for you to do today. So there's your pre-lab for what to do. Now you're probably like, well, how do I actually do this? Well, I will promise I will show you, because the whole process does not take very long. You measure 2 things out, you mix them together, it forms a solid, and then you filter it. And so in lab, it'll be kind of a minimal amount of time, and I will show you next time I see you how to do everything and where everything is. But this is a written diagram of the procedure, and I think it was pretty fun. I really enjoyed chatting with you, and I hope that you're all doing so well. Everyone take care. Okay, bye.